Alright, time for physics.com, debatephysics.com. Also, video presentation. So the debate's getting a little better. I've gotten Paul Nord to provide kind of explicit answers to some simple questions, sort of. And, just revealing, frankly, um, yeah, they're not going to present evidence. They're just going to keep arguing for a theory. And the theory, again, they don't think I should be persuaded by evidence. I should just be persuaded because they say so. And that's the part that's just being revealed, is that it's just a matter of faith, not a matter of reasoning, logic, and facts based on experimental proof. So anyway, he has a video he did link to called Tug of War, but unfortunately it has nothing to do with an actual comparison of something's actual energy. It's basically just an argument for friction. And it's all quite deceptive because, the whole beginning of the video, sort of like Steve Mould, it's all fake premises. He shows a certain scenario that doesn't seem intuitive and then explains, well, yeah, I did spill a bunch of glycerin all over the table, so it's very slick. And so it's an argument about friction, not an argument about momentum and energy, which is unfortunate. But anyway, it's better than the usual nothing. So we'll go to the last parts of the thread here. And I will have to move this out of my way and find some way to read this at the same time. All right, so he did a comment where he's just doing the same crap about somehow I don't already understand Galilean gravity, where he pointed out that it's the odd numbers, 3, 5, 7, 9, and that's the square of those numbers produces how many units of distance you have to lift something. So to get to get twice the velocity, you can lift it 4 units of distance. To get 3 units of velocity, 9 units of distance, and 4 is 16, and 5 is 25. And so this is all stuff I know, and I really don't, it's really not part of this conversation beyond the fact that I've brought it up as a point because the contention is the whole thing started with Leibniz making the declaration that 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. And the simple argument is they're completely different momentums. The 1 dropped 4 only has twice the velocity. It only has 1/2 the momentum. And it clearly will not do the same work. Something with 1/2 the momentum is not going to do the same amount of work. So that's the point of this whole argument, is their contention that is true, and my contention that it's absolutely false, and there's zero evidence it's true, and everything points to it being false in the sense of all the experiments you can list. Momentum fails. Kinetic energy fails, sorry. And momentum is always conserved. So starting with levers, the law of the lever is you conserve momentum. That's the law of the lever. Law of the lever isn't conservation of kinetic energy. All right, so I stated you're just making my arguments for me. You are conceding that a 1 mass drop 4 units of distance is only in the gravity 2 units of time and only collects 2 units of force. And again, this is back to Newton. Twice the force, twice the velocity. 3 times the force, 3 times the velocity. Not 9 times the velocity, 3 times. All right. Your own statement verifies that 4 pounds dropped 1 foot is not the same force as 1 pound dropped 4 feet. Not the same momentum, not the same capacity to do work. All right, so then I said, I've attempted to get you to answer simple questions, so I won't read the questions because I have to read them when I read his reply, so we'll do that instead. All right, so he starts off with more insults, frankly, and it's whatever. Okay, this is how they play. Somehow everybody who's going to make an argument countering some declaration, some dogma, they'll say that somehow they're ignorant and they haven't researched it or some other kind of garbage. So if somebody tells me I don't know Jesus, because I haven't let him into my heart or some kind of crap like that, and it's the same kind of jargon. Like somehow they have the inside knowledge, and somehow I haven't allowed the knowledge to be absorbed. It's just such bullshit. Anyway, it's difficult to answer your questions if we don't agree on the definition of force. Well, what's to agree on? Did Newton say it? Is Newton right? Twice the force, twice the velocity, 3 times the force, 3 times the velocity. Is that correct or incorrect? All right, we both know what mass is. Where are we disagreeing about what a mass is? And momentum and energy are defined by formulas. So what the hell's there to disagree about? I say momentum is mv, and I say it's the only thing there is. And I say mv squared is a silly formula. It has nothing to do with reality. What's complicated here? So again, just pretending that this is about semantics and about wordplay, when no, it's an overtly different thing. MV and MV squared are 2 entirely different concepts of energy. And yes, you're saying that the only concept of energy is somehow MV squared, and that momentum doesn't even have anything to do with energy. And yet momentum's the thing that has to be conserved. It just doesn't make any sense at all. All right. I think that we agree on distance. Well, I don't care about distance because I know it doesn't have anything to do with it. The only reason why the distance matters is because distance affords you time to collect the force. You collect the force by being in it and collecting it. You collect wind by being in the wind a certain amount of time. You collect a suntan by being in the sun a certain amount of time. It's not about the distance. All right, regarding your first statement, you are clearly still confusing, so I'll just say the same to you. You're just a little too ignorant. Yeah, you're ignorant. Ew, ignorant. Force, momentum, and energy. Yeah, well, whatever. I mean, what's the counter argument to that except some sort of same to you? Okay. So I'll leave it there. The potential energy added to a mass raised to a height of h is mgh. And again, I already made it clear to you, I don't believe that's a correct formula. It doesn't get a right answer. The one mass dropped 4 distances does not have 4 units of energy. It doesn't. It has 2. It was in the gravity 2 seconds. It has 2 9.8s. And the velocity proves it's only 2. Right. To know the velocity of an object after freely falling that distance h. So again, I've made the argument that if a meteor is coming into Earth faster than this, at thousands of miles an hour, gravity's not going to give it any extra velocity because it's going to plow through the gravity so quickly the gravity will have no time to act because it's already here before the gravity could do anything to add any velocity. So it's almost irrelevant. All right, and how many times do you have to make these arguments? And he really won't pay attention to them. I mean, if I detail them here, will he watch the video? Probably not. He didn't even watch Steve Mould's video because he's misunderstood it. All right, and converting all of that potential energy. So again, it's not any potential energy. It's a stream. Gravity's a stream. You place things in it and watch them move by the stream of energy. The energy is collected from the stream, just like a boat being put in the Mississippi River. It wouldn't make much sense for me to say, oh, there's a boat on the shore. It has potential energy. No, it doesn't have shit, all right? It doesn't do anything until you put it in the stream. All right, and potential energy to kinetic energy. You can calculate, so he just keeps doing this. Pointless nonsense. And I can say, I can calculate it too using MGT. So what? You're not proving one or the other this way. This isn't an experiment. This is just an assertion that I completely disagree with. Okay. If you double it, do you double the velocity? You do not double the velocity. So there you're proving the point. That gravity is a time dependent. If I go 4 times higher, it doesn't take 4 seconds to fall. It takes 2. There's only 2 units of time. Only 2 units of force collected. 9.8 meters per 1 second. What is hard to understand about that? So again, if you just want to throw these stupid equations at each other, I'll just keep saying that over and over again. It's 9.8 meters per 1 second. Not seconds, not seconds squared, not seconds per second, none of that crap. Per 1 second. 1. All right. If you double h, do you double the velocity? If you double h, you do not double the velocity. This is really simple to check with video analysis. More nonsense. So again, where am I debating this? So just lie some more. I mean, this is really such a garbage argument to make, but I've been arguing right from the very beginning. All right, that 4 times the height is not 4 units of energy. It's not 4 units of time. It's not 4 units of velocity. Where did I argue otherwise? Oh, God. So it's just so... Anyway, here's a simple physics lab with exactly the problem you just described. I didn't describe it. You just described this nonsense. I didn't describe it. So this is just such bullshit. Okay, so all this is dropping an object at distance, and the fact is it goes faster and faster. So who's been fooled? So again, there was never in my argument that I argue dropping it. I don't even know what you're arguing. That you don't have to go 4 times higher to double the velocity. Of course, that's exactly what I've been arguing. And they have to go 9 times higher to triple the velocity. That's exactly what I've been arguing. All right. I'll offer some comments to your questions, but we are not agreed on terminology. So again, this is the nonsense part. It's black and white. It's dog versus cat. Simple. I mean, I'm saying the cat is a cat and the dog is a dog, and you're saying vice versa, opposite. You're saying mv squared has something to do with reality. I'm saying momentum has everything to do with reality, and that mv squared has nothing to do with reality. It never gives you a correct understanding or definition of energy in the universe. It is always wrong. There's not much we can accomplish. So again, it's just a fake argument that somehow I don't understand the argument. I mean, I can't make it any damn clearer. I don't think mv squared ever gets a right answer. I'm asking you to produce some evidence that it gets a right answer somewhere. Oh, shit. Let's take a break. Alright, so here's the question part. So I ask, consistent with the law of the lever, do you believe levers conserve momentum? Half masses twice the distance move twice as fast. Okay, and his answer is no. So in spite of the fact that there's a thing called the law of the lever, in spite of the fact that it's what was believed for thousands of years, he's claiming it isn't true, and he's claiming that there's somehow some reasoning for him to believe it, when all he's saying is my formula says no. And so I believe my formula, so my formula says no, so it must be no. And that's all. So it's not an evidenced argument or a reasoned argument or a logical argument. It's just faith in 1/2 mv squared, or F equals ma, as he ends his statement with. Okay, so here's his answer. Depending on how you describe the lever problems, there's nothing to describe, okay? You put a 2 mass in going 1v, can you get a 1 mass out going 2v? Do you conserve the momentum? Is this a complicated question, really? Does any of this depending on crap have anything to do with it? No. All right. The lever generally exerts an external force. So you say so again. What external force? It doesn't have anything to do with any external forces. You're saying you got one object moving in, you got one object leaving, coming out. And yeah, you lose a little bit to the lever itself. That's it. That's all that's in the equation. So you might take care in applying the conservation of momentum laws. So I'm saying within 10%, okay, that you're going to conserve the momentum. I'm taking out the weight of the mass of the lever itself, because obviously you're going to have to move the lever to move the objects. But other than that, okay, you're going to conserve the momentum. I guarantee it. We discussed a freely spinning rod. Yes, because you were playing gravity games. So the spinning rod gets rid of the gravity gains. Momentum was conserved in that case. So how is that case any different? If the lever's going up and down, you're telling me it's going to behave differently than side to side? So let's just leave it side to side then. I just put a lever. I don't need a spinning thing. Let's just put a lever horizontally. Okay, and we're just going to plow into it on one side with a 2 mass going 1v. And we're going to see if we can get the 1 mass to come out at 2 velocity from the other side. And I'm saying it's a guarantee you're going to. Because the lever is going to move identically for both circumstances. Let's see. Momentum was conserved in that case. So this is bizarre. I didn't even realize he was saying it was conserved in that case. I thought you said it was hard to spin the wheel with the masses on the outside. So this is a contradiction right there. He actually did argue it. He argued that the lighter masses on the outside of the wheel are harder to push than the heavy mass on the inside of the wheel. It requires more energy to acquire the same momentum. That was what he said. Alright, Steve's mistake. So he keeps saying that Steve made a mistake, and that's the joke here, at about 5-minute mark in his video. So the 5-minute mark is where Steve is still saying, look, my intuition says the law of the lever is a real thing, and it should fly out with twice the velocity. That's the whole pun. That was the whole joke of his video, is that he was setting up a false premise, and then he was going to explain how, see, my intuition was wrong. And the truth is, it comes out with 1.4. So I'll just play the clip. So obviously he didn't even watch the video he made a response video to. I mean, I have to say he didn't watch it, right? Because it's just clear what Steve did. I mean, it's clear. So leave us play it.
Must be from that. But if we're trying to disprove the free energy hypothesis, we should probably prove that the half-kilogram mass has a kinetic energy of 1 joule.
So he was saying the free energy hypothesis would be, well, yes, if it conserves momentum, then it just made free energy, because the lighter object will have twice the kinetic energy. So if the momentum's conserved, I've created free kinetic energy. So he's saying, well, that can't happen. So instead, he's going to destroy the momentum. He's going to kill 1/3 of the momentum instead. And say that solves the problem. When, oh no, that's another new problem you've created, bucko. Again, these two theories are not at all compatible. You cannot say that in any experiment where you're going to transfer energy from different masses, you'll never conserve both the kinetic energy and the momentum. It's just not possible.
From a force perspective first, which is actually really easy. The key is to notice that the force on the half-kilogram mass is half a newton, because that's how mechanical advantage works.
So this is at 1040. Okay, this is the point you should have watched. This is what Steve Mould is actually saying is the truth.
The work equation, we get half a newton times 2 meters.
So we use the circular mathematics. The work equation justifies the silly 1/2 mv squared equation. What did I just do? Well, probably not something significant. We'll just continue.
Is 1 joule. You then get the velocity by rearranging the kinetic energy equation, and when you do that, you find that whatever the final...
So whatever, the answer is 1.4. Okay, so he even writes it on the screen at one point here, right? So, I mean, he's arguing what you're arguing, Steve, Paul. He's saying, yeah, it only leaves with 1.4. It destroys 1/3 of the momentum. It doesn't obey the law of the lever. That's your assertion, and you have zero experimental evidence showing that to be true. So that's the argument. And clearly, the balance proves it to be nonsense. The balance doesn't have any hard time moving the half mass at twice the velocity. No problem at all.
Velocity of the larger mass was the smaller mass, instead of being double the velocity, it's √2 times the velocity of the larger mass. So that's when...
do you understand that √2 is 1.4?
My intuition went wrong. These two spaceships...
And again, if it were 1 to 3 mass, if it was a 1 to a 3 mass, then it would be 9. And then if it's 1 to 4, it's 16. It just gets more and more outrageously preposterous in terms of how much free energy this silly experiment would be creating if you actually did it.
in these two different scenarios don't have identical experiences. One of
So again, there's obviously are identical. Okay, you're accelerating something, you're decelerating the one object, and you're accelerating proportional to the mass. So the half mass is going to be pushed twice the amount of distance, over twice the distance. It's going to have plenty of time to acquire twice the velocity.
them moves more slowly. But I still think it's a compelling line of reasoning. Like when I've presented it to smart people, it hasn't persuaded them that you can get 2 joules from 1, but at the same time, they weren't able to immediately tell me where I'd gone wrong. You know, I bet I could persuade a few people to invest in a free energy device just by running.
So this is the joke. It's free something either way. So you've just shown how you've destroyed momentum, which you can't do. And again, if I reverse it and do it the other way, then obviously I'm making free kinetic energy. That shows the incompatibility of these two theories of reality. You have to choose one. I would suggest choosing the one Newton and Galileo and Descartes believed in, which is momentum.
Running them through my space lever slide deck. It'd be a good way to make a bit of money as well. Not that I do it, obviously, because, I mean, it'd be a hassle, wouldn't it? Like
yeah, why don't you actually make it? So go ahead, make the device and then prove it. So, I mean, I can tell you, I can do the pendulum thing and I can use your theory and make a free energy device based on your theory. But obviously it won't happen because your theory is nonsense. It doesn't work. You can't give things free kinetic energy. You can't give them free momentum. We can give them free kinetic energy because it's not a real energy. It's not real.
I have to contact hundreds of investors and chase them all up and keep track of where I was with each one. I need some kind of CR.
Oh, okay. This is where he does his commercial. So yeah, you have to jump ahead. I'm not going to be bothered just to see the 1.4. But clearly that's his argument. So Paul doesn't even understand that Steve Mould is arguing that you can't make the half mass go twice the velocity. Even though that would conserve momentum, if you did, you can't do it for some reason. And there's no reason articulated, no explanation for where the momentum is lost to, where it's hiding, what element of the lever destroyed the momentum. No, there won't be any of that. All right, take a pause. Alright, should be picking up where I left off, I hope. Okay, momentum was conserved in that case. Steve's mistake at about 5 minutes mark in his video. So let's understand the 5-minute mark, he was setting up the false premise. That's not his assertion, the 5-minute mark. His assertion is at the 10-minute plus mark. Alright, was exactly that. The answer is no. Okay, the two objects will experience the same acceleration in Steve's example. The two objects will experience the same acceleration in Steve's example. So they obviously can't experience the same acceleration, so that doesn't even make any sense. One of them is going to be going twice as fast. 1.4 as fast. Even going 1.4 is more acceleration. But to move twice the distance, as described in Steve's problem, it has to move twice the distance. It's a lever. But anyway, will take longer with the same acceleration. It can't take longer. Can't go faster and take longer. So yes, it can only go slower to take longer. And taking longer means you didn't apply more energy. You have to apply less energy to take longer. So the whole thing makes no sense at all. Absolute garbage. So at least I've got him nailed down. So he's saying the law of the lever is a nonsense. It should be taken out of physics because it isn't true. That Archimedes dissected levers incorrectly, that Galileo got it wrong, and Newton got it wrong. Yeah, and I'm the science disrespecter? No. Obviously, these people are. All right, question 2. Do you believe pulley systems conserve momentum? So the minute physics clip is right in the video. I'm not going to play it again, but clearly minute physics drew it, explained it, stated it, and he didn't overtly said, obviously momentum is conserved, but he basically drew it as conservation of momentum. The half mass does in fact, for the same newtons of pull, The half mass moves twice the distance in the same time. That's twice the velocity. Again, there are external forces. So there's no external forces. It's just, again, a canard, just a distraction, a red herring to talk about any external forces. There's just you pulling on the rope and the force of gravity that you're overcoming, or even without the force. Again, just pushing. You can put it pulleys horizontal also. You can use them to move a car and do other things. So this isn't just about gravity. It's just about applying momentums and converting momentums. And that's all the pulleys does. That's all the lever does, is convert big M, little v, into big V, little m, and vice versa. And that's all that pulleys do. That's the absolute physical fact. These guys are propagandizing for some other nonsense, and they're just perverting young minds with this fake narrative that isn't true. They have no evidence to defend it, and they just keep preaching it. And it's a kind of child abuse, frankly. Because it's religion. They should just call it what it is. It's religion. It isn't science. Some kid interested in science is not going to learn science from these people who don't respect experiments and don't understand the necessity to prove what they state with experimental evidence. All right. The total momentum may be conserved. So what kind of bullshit is this? It may be conserved? Well, can I conserve it with a lever then? If I may be conserving it with pulleys, can I maybe conserve it with a lever? What does that mean? It either is or isn't. Okay, this is he's talking about not agreeing on vocabulary. We don't agree on what are reasonable, perverse sentences. This is not a proper statement. Maybe. But not the vector quantity. So what does that mean? The total momentum may be conserved, but not the vector quantity. That's all the momentum is a vector quantity. That's all momentum ever is a mass moving a direction at a velocity. That's all there ever is. There's nothing else but. So how can the vector quantity be conserved or not conserved, and the momentum be conserved and not conserved? That's just nonsense. Consider a perfect elastic ball bounce. Why would I bother? There is no such thing in our world, right? Steve Mould did an experiment where he got pretty close to perfect, in the sense he got 200 bounces on top of a hard surface. Is it your argument that there was twice as many elements of momentum went into the surface, that it was hit with thousands of times more momentum than the ball had when I first threw it down or let it drop? That's the nonsense of your theory, and frankly it is nonsense. Okay, that every time the ball hits it puts twice the momentum into the ground? That's nonsense. The momentum may have the same value after the bounce. So what does this have to do with pulleys? Oh, that's right, nothing. Yeah. But its direction will be different. So its direction is different with the lever. Its direction is anything I want it to be on a spinning wheel. Direction is irrelevant, as these experiments all point out. You can change direction without using any energy. You don't have to consume energy to change direction. Of course you can, but you don't have to. All right. So, third question. Do you believe that rocket thrust can give a rocket more energy than the momentum of the thrust? So this goes right to the core of it. Where's the evidence of kinetic energy if it can't move a rocket in space? It can't move a spaceship. You can't navigate with it. If it can't push something in empty space and actually work, that is, I use 10 joules of thrust and I get 10 joules of energy in my motion. If it can't do that, why are you defending it? I mean, it's failing the most elemental test it could fail, and it fails it. Let's see what his answer is. I didn't bother reading some of this just because these answers are just bullshit. All right, you're asking me to compare momentum and energy. Well, what the fuck do you think this argument is about? I'm asking you to show which one actually does work in the universe. I'm asking you to show me a car going twice as fast doing 4 times the damage. That's your theory. A car going 5 times as fast do 25 times the damage. That's your theory. Yeah, I'm asking you to defend it with evidence, or at least reasoning, and you're doing neither. All right, the question makes no sense. I mean, amazing. Just absolutely amazing. Clearly, if I throw a can of tomato soup, right? I throw a can of tomato soup, I'm in space. What am I going to get? Am I going to get the recoil, the equal and opposite reaction? Is the equal and opposite reaction going to be the kinetic energy of the can or the momentum of the can? Clearly, the kinetic energy is going to be a different joule number than the momentum. Which one am I going to acquire? That's the simple question. And he says the question makes no sense. Can you see the evasion here? Will you admit the evasion? These people are supposed to be serious about science, serious about understanding the truth and facts, and this is what he says. He doesn't understand the question? Bullshit, he doesn't. He's just evading it because he doesn't have a good answer. You might as well ask, can the density of a glass of water change its mass? So what the fuck does that have to do with anything here? So you ask a simple question, you get absolute crap as a response. I mean, that's just crap. I mean, oh, it's so obnoxious that they get away with this, that you people do not hold these people to any account. This is a fucking a college graduate, okay, a guy with some degree in some science, and this is how he answers a simple question. Bullshit. All right. There are two different ways of describing the properties of a thing. So what's the point? It's dualities all the way down. Okay, it's waving particles, and it's heavy light masses, and it's light heavy masses. I mean, it's all just bullshit. Simple question, garbage is an answer. It's a simple truth. One science landed us on the moon. The science of momentum, thrust equals P, or thrust equals mv squared. One of those landed us successfully on the moon. The other one would have failed dismally. Have you ever seen a ballistic pendulum collect any more energy than just the momentum? Simple question. Yeah, I love this. It's just another evasion coming, right? You can just feel it. All right, in the general lab setup, potential energy is stored in the spring and then released. Who cares? We're talking about an object traveling, a bullet, a ball bearing. It doesn't matter what we're throwing at the pendulum. We're just talking about the velocity of the object. We don't care how it acquired its momentum. It has momentum. It has an mv, which means it has an mv squared. It already has it. It's not debatable who cares whether it popped out of a cork gun or what mechanism gave it velocity. We know it has it. Oh, this is such evasion. All right, some of that is transferred to the ball. Well, duh. So he's arguing as if we can't measure the velocity of a bullet, when of course we can. That we can't measure the velocity of a ball bearing, when of course we can. All right, you can calculate the launch velocity from the height reached by the pendulum. And again, that's the whole point. How do you calculate? You don't use mv squared. I'm telling you, you don't do it because it won't be conserved. And so he says Ke equals mgh again. What does the h have to do with this? It's a ballistic pendulum. There's no mgh in a ballistic pendulum beyond just understanding the motion is going up in gravity. But that's no use. There's no excuse for using mv squared here. So again, he says Ke equals mgh, where he's saying the mass times the gravitational constant times the height of the pendulum. Right, but that's still going to just tell you the relative comparisons are. It's just going to tell you what the momentum is, the momentum of the pendulum. You're perverting it with this 1/2 mv squared crap. And again, energy and momentum are not the same thing. This is just such garbage. Yeah, one thing is a real thing. The other thing is absolute fantasy, and you have zero evidence for it, and you're pretending you give a shit about the truth in science. It's disgusting. So again, he totally evaded the question. Have you ever seen a ballistic pendulum collect more energy than just its momentum? So every single ballistic pendulum experiment, if you calculate the momentum of the pendulum, pendulum, all right, you'll see that it's less than 80%, 85%, maybe 90%, maybe 95% of the momentum that went in. And it's never the kinetic energy. It's conserved, ever. Every single time you use a ballistic pendulum to catch any lighter mass, it will always lose kinetic energy. Now, I could show you Professor Lewin doing that. Do you think Professor Lewin doesn't understand? Are you going to say Professor Lewin doesn't know the difference between momentum and kinetic energy? So when Professor Lewin says, writes it on the board, you lose 99.94% of the kinetic energy. What, you think he doesn't know what he's talking about? I mean, you're just such liars. God damn it. I wasn't going to get angry, but fuck. What deceptive, lying scum. Alright, so just a note to the future. So you can't make it any simpler than this, right? Simple questions, evasive nonsense answers. No direct evidence of anything they claim. That's their science. That's the integrity of them as scientists. They're not believing based on evidence. They don't say, show me. They just say, tell me. And I will believe. I'll be a believer. Just a religion. It doesn't qualify as anything more than religion. All right. Have you ever seen a car going twice as fast, do 4 times the damage? Now, I could make it 3 times as fast, doing 9 times the damage. I could do it 4 times as fast, going 16 times the damage, or 5 times as fast, doing 25 times the damage, which is absolute nonsense. Qualifying damage done is pretty tricky. So they do it all the time, okay? And there's nothing tricky about it, okay? The Mythbusters crashed 2 cars, 100 miles an hour, 50 miles an hour. It couldn't be closer to exactly 50% of the, twice the crushing. Not 4 times the crushing, twice the crushing. All right, here we might have a fun discussion of the impulse momentum theorem. So again, I'm not interested. I don't need any impulse momentum theory because you're going to convert that even into garbage. So the truth is that if you're going to argue that there's such a thing called impulse momentum and it's real and that it conserves momentum, then your kinetic energy theory is false. You cannot have a momentum theory and a kinetic energy theory. You either have to be all one or all the other. That's physical reality. Physical reality doesn't play duality. All right, the maximum force will depend on the rate of change of velocity. Some more nonsense. No, it's going to be completely dependent on the fucking velocity going in, the momentum. And it's perfectly conserved. So again, more nonsense that somehow momentum isn't perfectly conserved when it's perfectly conserved. I can gradually increase the momentum of the car, and I will gradually increase the denting of the car. And that also depends on the initial velocity. The only velocity that matters is the impact velocity. So again, bullshit. So he just says things are just garbage. The initial velocity is completely irrelevant. All that matters is the impact velocity. We measure this in the lab. So again, more bullshit about they doing some kind of lab. No, you're doing it in your cathedral. Okay, it's not a lab. You don't do anything honest in there. You just do propaganda. All right. Let's see, the measure of this in the lab with a video of a karate board. Oh, so this guy is really obsessed with this, frankly, show physics. Look, I can break a board with karate. Oh, maybe that impresses 10-year-olds. Maybe. Okay, the board can flex about 2 centimeters before it breaks. And again, and what does that have to do with kinetic energy? Any theory of kinetic energy, breaking things. I could show that with a piece of glass, and I could heat it unevenly and it cracks. I could heat it evenly and it doesn't crack. It doesn't mean a damn thing. It doesn't prove there's more heat. It doesn't prove there's more energy. The fact that you can fracture things that can't absorb the energy in the time you've allowed them to doesn't mean a damn thing. It doesn't mean it has more energy. It just means that things are fragile. And high velocities can break things. And slow velocities are less likely to break things. But if I want to knock a building down, I'm going to use something that's heavy and slow. Fact. Because it works better. It does better work. So it's just silly. This is like pointy arrow nonsense. If I point an arrow, that means it has more energy because it goes deeper because the arrow is pointy. Applying energy on a smaller location with a higher velocity is not a demonstration that it has more energy. Okay. If it brings a hand of mass m to a stop in 2 centimeters, we can estimate the force required. And again, it's going to be just momentum, frankly. The bottom line is it's just momentum. And the fact is, to break a board, you have to achieve a certain velocity before the board will break. It'll just bend until you achieve that breakage velocity. If you double the velocity, the force required to stop it is the same distance quadruple, says you. Okay, that you have no evidence of. 0. There's no evidence that anything quadrupled. So, bullshit. Show me. Show me the experiment demonstrating that to be true. Alright, he won't do that. Yeah. Show me where it's measured clinically. Again, I could just argue. They've known of this science for hundreds of years. Joule invented the Joule tank literally 200 years ago. Alright. And have they shot a bullet into it and then let the recoiling gun go into it and then measured how warm the water got? No. Why? Because it would prove the point that the only thing the bullet has is momentum. Let's see. Have you ever seen a turbine spun 5 times as fast produce 25 times the electricity? I can't wait for this one. Yeah. Conservation of mechanicals. Now he's using the term mechanical energy. What the fuck? So let's just keep changing the jargon to electrical energy depends on some other complex physics. No, it doesn't. So that's just more lying. It's exactly has to do with momentum. Momentum spins things. Momentum is what they have. They have angular momentum. So again, more nonsense. Absolute nonsense. The stream, the water in Niagara Falls has momentum. That momentum is converted into a spinning turbine. The spin of that turbine has a momentum built into it, and it is going to produce the electricity because the electricity is going to apply a counter torque to the turbine. And the fact is, twice the spin, twice the energy. 3 times the spin, 3 times the energy. Not 9 times, 3 times. Alright. It's not so much about the speed of the turbine. Bullshit. Okay, so it's just a lie. No, it's everything to do with it. A motor is about the speed of the spin. Everything. Okay. As it's about the rate at which the energy is converted from one form to another. So just more of complete evasion. All right, so just evade the subject. Your argument is it takes 25 times the energy to spin a motor 5 times as fast. That's your argument. Defend it. And defend it with a piece of evidence. God, there's such weasels. Sorry, I mean, this is outrageous nonsense. Evaded every single question. All right. So, do you think a one-mass cart going 5 velocity will win a tug-of-war 25 times over against a 5-mass cart going 1 velocity? So that's their argument. The 1-mass cart going 5 velocity has 25 times more capacity to do work than the 5-mass cart going 1. That's their theory. And what's his statement? Curiously, this has more to do with friction. So it doesn't have anything to do with friction. I can do it in space. So again, more lies. We're not talking about motorized carts. We're talking about a mass. I push it. I push it. They travel a foot or two, and then they have a tug-of-war string that stops them. They don't have motors. They don't need friction. They don't need torque. They don't need any of that crap. They have a mass and a velocity. And the argument is one of them, by your definition, has a kinetic energy that's 25 times the power of the other one. And the evidence is it won't work. The fact is the bullet and the recoiling gun, the bullet will not win by 1,000 times. It will not move the recoiling gun 1,000 times more. It won't do any of that. It'll be a stalemate. Absolute fact. Damn it. And if you do the damn experiment, you'd see it was an absolute fact. Alright, this is more to do with friction on the cart against the surface. So it has nothing to do with friction. You could do it with boats. You could do it in space. You can do it a whole bunch of ways, and it has nothing to do with friction. Increasing the mass increases the normal force. You can't increase the normal force, sorry. In the sense that it's always going to be countered by gravity from, the Earth pushing back up. So it's, a moot point. The fact is his experiment actually demonstrates, the one I showed in the beginning, which I'll play in a separate video, I guess. It's just a friction argument. That's the very friction argument I've used about rolling objects. The faster you roll something, the faster it's moving on a surface, the less friction it has with the surface per inch. Duh. Okay, increases the normal force and gives you more grip on the road. It also gives you more capacity to lose energy to the road. So in the case of a rolling object, the twice as fast rolling object will roll 4 times as far because most of the time it's going faster, and so it's much less friction per inch on the surface it's rolling on. Generally, look, you can slide across thin ice. It works. If you go fast enough, gravity doesn't have time to give you your full weight on the ice. So the ice says you'd only weigh 5 pounds. You don't weigh 150 pounds. Absolute fact. Generally speaking, the heavy car wins. Oh, it's just amazing. Absolute lie. So there's no generally speaking. You didn't do the fucking experiment. So it's just amazing. I did a video on this. You didn't do a video on this. You put fucking glycerin on a table and then said, what car can beat its static friction better? Slower wheels, faster wheels. Heavier cart, lighter cart. It's just about friction. It had nothing to do about momentum or kinetic energy. Nothing. Just an amazing, again, deception and distortion. And just an absolute lie. Generally speaking, the heavy car wins. Bullshit. And even if it's true, frankly, so why don't you just answer my question? Do you think a one-mass cart going 5 velocity will win a tug-of-war 25 times over against a 5-mass cart going 1 velocity? So his answer is yes. I think the heavy cart wins, which is basically just saying kinetic energy fails. So that's what he just said here, right? Generally speaking, the heavy cart wins. Now, I was just arguing that neither cart wins. But he's conceding the point right here. He's saying the cart that has 25 times more kinetic energy doesn't win. It has 25 times the energy, and somehow all that energy fails to deliver any work. So just sit there and think about that for a minute. Is it possible for him to say, I'm doing a good job defending my theory when he's just conceded the theory doesn't work in something as simple as a tug of war? Oh, just disgraceful. All right, so that's probably enough for this video. There's no way not to get angry. It's just because this isn't arguing fairly. He didn't fairly answer the questions. He didn't fairly cite any credible evidence relevant to the subject. And just made declarations again saying, I believe in my formula. Well, that's not science. Your belief isn't science. Your faith isn't science. Science is showing, proving, demonstrating. And you can't do that with credible evidence. Okay. It's probably enough. I mean, I should have asked him, are you aware of the de Chardolay clay experiments? Grandsons, I guess his whatever his name was. The guy who believed in perpetual energy, by the way. His clay experiments. That denting clay with round objects. Denting clay, not penetrating, just denting the surface. Just a little dimple is a good way of measuring absolute energy. And I would argue it's about as good as putting pointy arrows against dull arrows and saying pointy arrows make the arrow have more energy. It's just as dumb. All right. So, can't believe it. So even when you get them to, in some way, engage in the argument, this is what they do to it. Just keep changing the subject. So at least we did get out of him. He doesn't think the law of the lever is a real thing. He thinks that's bad science. And yeah, and he does think that cars. Yeah, did we ever do the stopping distance? Maybe I didn't finish that. With the karate, no, he kept just talking about karate boards. It brings up. Let's see. Yeah, he just keeps doing. If you double the velocity, the force required to stop it in the same distance quadruples. Yeah, no. So he didn't bring it up. So yeah, there's just no, no accounting for what they claim the truth to be, and demonstrating it with a piece of physical evidence. And again, it goes as simple as just even a lever. They're claiming you can't, use the same force, you can't make a half mass go twice the velocity, applying the same force as a one mass going one velocity. You can't make a half mass with that same force go twice the velocity, which is just absolute nonsense. But anyway, all right, till the next time and such and so forth and whatnot. I mean, you can understand if I used a stick, like pili, is that what it's called? Pili, whatever. Yeah, and I extend my hand with a stick. And so I throw the ball with my hand, or I can throw it with the end of the stick, a half mass ball at the end of the stick, twice the distance. My arm and my muscles will do exactly the same work to create the twice the velocity and the half mass as I would have to do with the full mass throwing it. It's going to be exactly the same work, the same motion. My hand will move exactly the same. My muscles will work just the same because it's the same as the pulley. It does in fact conserve momentum, and they're just wrong to say it doesn't. They're evil. Yeah, that's what it's. This is evil. Pretending, trying to shove religion in the mind of man and calling it science. That's evil.